Okay, so one of the final things you're going to be asked to do with the basic trigonometric identities is to solve a problem. Notice this is different from the last because it's got numbers in it and it's equal to 0. It could be equal to a number. It could be equal to anything. But on a solve, the goal of the problem is going to be to find the angles that work for theta. So in other words, you have a theta in the problem, so your goal is without a calculator to find what is theta. Is it 0? Is it pi over 6, pi over 4, pi over 3? So in order to do that, you solve this just like you solve an algebra problem, okay? So whenever you have an algebra problem, pretend that that was just an x. Well, if I had the square root of 3 times x minus 2, what would our goal be? Well, our goal would be get x by itself. So that's the goal of this problem, get this by itself, and then we can try to figure out the answer. So how do I isolate the secant? Well, the first thing is I would get rid of the 2. There's a minus 2, so I need to do plus 2 on both sides. Now, after I do that, my next step would be to get rid of the coefficient. So how do I do that? Well, I just divide by it. Okay, so now I'm looking at the secant of theta is equal to 2 over the square root of 3. So when you see this, you may be like, well, I don't know, like how am I supposed to solve that? Well, here's a nice nifty little trick, okay? What is the secant equal to, everybody? Well, the secant is just 1 over cosine. So, in other words, it's the reciprocal of cosine. So the way my brain does these problems is I'm like, I wish that wasn't secant. I wish it was the word cosine instead. So what I do is I'll do the reciprocal of this side. So the reciprocal of secant is cosine. And then I'll do the reciprocal of this side. And just like that, by just flipping this fraction and turning this into its reciprocal function, now this is something my brain can do because I've memorized all of my cosines all over the unit circle. And if you have 2, then you know that this is either pi over 6 or the one below it, 11 pi over 6. So that would be, those would be your 2 answers. X equals, or not x, this is a theta. Theta equals pi over 6, comma, 11 pi over 6. Okay, let's try another one. Okay, so same kind of idea. We're trying to isolate the word, the trig word. So I want to get this by itself. So my first step would be to add 1 to both sides. Then what? Well, then I divide off the coefficient. And this is where some people get a little weird. Anytime, this is tangent squared. I really don't want it to be squared, so the opposite of squaring something is a square root. Just remember that when you take a square root, you do need a plus or minus, okay? So I'm going to be left with the tangent of x equals plus or minus the square root of 1 over the square root of 3. Now, if you simplify this, guys, what is the square root of 1? Well, it's just 1. And what is the square root of 3? Well, I don't know. It's the square root of 3. So you could write your answer like this, or if you rationalize that, it's root 3 over 3. So either of these are the answer. Now, it may not look familiar to you, but what I beg you to do, because this is going to show up a lot in this section, you know how you've memorized these 3. I know you've memorized the points, okay? I'm going to ask you to also go ahead and memorize the tangents because it'll save you a lot of time. So at any pi over 6, okay, at any of the over 6's, the tangent is root 3 over 3. At any of the pi over 4's, the tangent is always 1, and at any of the pi over 3's, it's always the square root of 3. So when I get an answer like this, I don't get scared because my brain already has memorized, oh, that's going to be any of the over 6's. So it's plus or minus this, which means, guess what? It is all of the over 6's. So let's try to remember all of them all the way around. Pi over 6. The next quadrant, 5 pi over 6. Then down there, 7 pi over 6. And lastly, 11 pi over 6. So yes, there are 4 answers to this problem, and that's how it's going to go. We're going to do one more because this is important and these look all different, and this is what I would think would be like the hardest of them. Okay, so here's the grand finale. This is as hard as they get, if you ask me. Alright, so the first thing is, what makes it hard is there's 2 different trig functions. There's a sine and a cosine, and you're supposed to solve, so you need it to really be the same word. So you either need to turn cosine into sine, or sine squared into cosine. So the one that's the only one that's possible is this one, and here's why. There is nothing up here that turns a cosine into a sine. But if you have a sine squared, then you can look at this identity and you can do a substitution. So what if I took this definition and got the sine squared by itself? What would it equal? Well, I would have to subtract cosine squared here, and I'd have to subtract cosine squared here. So what it would look like is, instead of sine squared, it would look like a 1 minus a cosine squared. So this is me just isolating the sine squared in this equation, then plugging that in right here. Okay, now I'm going to copy the rest of the equation. Okay, now what? Okay, now we need to distribute, so this will be 2 minus 2 cosine squared theta minus 1 equals the cosine of theta. So if you're wondering, like, well, what do we do now, and this looks confusing, okay, if the word confuses you, remember you can go in and you can just write an x in its place instead, or a y, or whatever letter you like the best, if it helps you. But we're trying to solve this, and I can already tell it's going to be a quadratic because there's something squared, there's a normal term, and then there's numbers everywhere. So like I said, if it helps you as you're simplifying, just turn that into an x, and it would look like this. And now how would you solve that? Well, you could, I would probably bring the minus 2x squared to the front. I would subtract the x over to this side, and then 2 minus 1 is a positive 1, and there would be a 0 over here. So this is me just bringing everybody to the left and cleaning it up a little bit. Now when you have something like this, you're supposed to factor it if it can factor. I don't like to factor with a negative in the front, so I'm going to change everybody's sign. I'm going to multiply by a -1 to make that happen. Now I can factor this. Okay, if I have to factor this, this is a 2x and an x, what would that be? I need a 1 and a 1. The middle has to be a positive 1, which means this would be the plus, and that would be the minus. Alright, cool. So now that we've done all this work, we're supposed to solve, so you're supposed to set each parenthesis equal to 0. So this is just old school solving quadratics. On this side, okay, and once we have this, you know, you might be like, oh, I got my answers. No, you did not get your answers, okay, because this was not the goal. Remember, the goal is to find the angle where this happens. So once you've done all this math, don't forget at the end, put the trig function word back in, okay. This was a cosine that we just pretended wasn't there just to make it easier to solve. Now I'm putting that word back, and now we can find our angles. So where on the circle is the cosine equal to 1/2? Okay, well, let me think. That's the x value, and the x value of 1/2 happens here, and it happens here. So that would be pi over 3. Is this a theta? Yeah, it was a theta in this problem. And down here, what is that? 5 pi over 3. And then do the same thing over here, guys and girls. Where is the x value at -1? Well, doesn't that happen over here at pi? Okay, so this one has 3 answers. So I know this video is a little longer, but this one is a little more complicated. You can see all different kinds of stuff, but hopefully it helped. Let me know if you run into a hard one. Thanks.